Hello, everyone, and welcome again. So today, in this session, we're going to talk about securing operational technology, Internet of Things, and industrial Internet of Things and systems along with that. So it seems like a long collection of topics, but you'll see through the presentation why it's actually much simpler than it looks when we talk about extending the Zero Trust platform into securing these systems. Let me start out with talking about Safe Harbor. We are a public company. We're talking a lot of futures here and public forward-looking statements. So it comes with its risks and it comes with its potential. So I would advise you to read through this whole disclaimer section. With having completed this, let's move on to the exciting part of this session here. It's a quick intro about me and Manish here. I joined Zscaler about 9 to 10 months ago, leading the OT security team, making sure that we are able to take all the goodness that Zscaler has developed as part of its cloud security platforms and extending that over to the OT security side of the house. I'm joined by Manish here, who brings in years of experience from his Samsung IoT stuff or Okta experience of identity, where we work together as a team and make solutions possible for securing OT systems, industrial IoT, and IoT. Without much ado, let's talk about what we are going to really cover here. So we are going to talk about what are the real challenges when it comes to OT systems, IoT, and industrial IoT. They're not exactly the same. We'll go through the details. What are the key security considerations? It differs from vertical to vertical, application to application. And how are we envisioning extending the Zero Trust into OT and IoT? And one of the key things that we'll talk about is how one of our customers, Siemens, is going through with the secure remote access portion of it. How we are doing a joint partnership with them. And last but not least, we'll also talk about the security reference architectures for IoT and industrial IoT gateways. We won't be able to get through each and every deployment model that we have. We'll at least give you a flavor of all the different use cases, and then we'll end the session with like the next steps, what you can do, what are the takeaways, what you could be doing Monday morning, essentially 30 days from today and 90 days from now. So let's look at what are the key challenges, right? So when we talk to Manish and I, when we have conversations with OT security folks, it's vastly different than talking to IT security teams. They always talk about plant downtime, people safety. Even the most recent attack on this gas pipeline was more about downtime and how it affects people and plant safety to a large extent. It's less about cybersecurity. And the subtext here is air gaps are disappearing, meaning all these systems are becoming connected. New business models require these things to be connected. If you're unable to connect these systems and do data analytics and do predictive maintenance, you're essentially going to get outmoded and outwitted by your competition. So that's the theme here. You can't really avoid connectivity. We talk to a lot of customers where they're saying ICS employees or industrial control systems employees need internet access to be productive. So you can't completely air gap that. And we'll provide architectures as to how do you protect yourself against that. And the IT security approach doesn't work. These are unpatchable systems. Systems have been deployed for decades. These highly customized hardware and software. To give you a simplified definition of what is OT security, anything that is on the manufacturing floor. Let's say you have an iPad that's doing something with building automation. That is considered as OT security. Anything that's in the manufacturing floor, even a Windows 10 workstation, is considered operational technology. One of the things that's been ignored quite a bit is VPNs and firewalls. They are a big attack surface, especially on the OT side of the house. If you have a VPN, if you have a firewall that's facing the internet, even though it's security gear, that's what's been exploited. You don't have to do much, just Google for it and you'll find out VPN vulnerabilities or firewall vulnerabilities. And you'll see how they're affecting factories of the world today. A quick primer on what is IoT, industrial IoT versus OT or industrial controls. We get this question quite a bit. Does an IoT just mean the smartwatch that I'm wearing, or the smart TV in my house, or the smart TVs or smart appliances that are there in an enterprise? Yes, that's different. What we really mean by industrial IoT is all the sensor data that helps make these IoT systems run smoothly or increases the safety of that. We're really not talking about the IoT systems like your Nest devices. In the enterprise setup, IoT is your Nest device. And in some cases, it's your point of sale systems as well. the threat scenarios are different. On the OT side, it's people and plant safety, it's loss of revenue. On the IoT or industrial IoT side, it's not as dire in terms of consequences. Yes, you'll have data leaks, you'll have this, they become entry points for other attacks. So depending upon how you look at it, OT systems, the threat of plant and people safety kind of trumps the card when it comes to data breaches. So let's look at the OT security pain point. So if you look at it, this is called the Purdue model of security. We won't go through entire sections of here. So if you look at the ICS, which is the bottom 4 rung here, so there's different levels of it. So that's what we call as the on-prem or shop floor security. But since we are talking about connectivity and connected devices, we see a lot of use cases around secure remote access, meaning technicians wanting access to OT systems to do remote diagnostics and maintenance. This happens to be one of the big use cases today, especially in the COVID world. The second one happens to be the secure application access. This is your workstations connecting back to ERP systems. This is your industrial IoT sensors connecting back to data analytics. That's what it is. When you talk about secure internet access, this is the ICS employees or users from the manufacturing floor wanting to connect to the internet. Or there's a couple of workstations that needs internet access for, let's say, downloading updates, downloading software. So it's highly controlled access across the board when it comes to remote access, app access, or internet access. Then there's a whole section of challenges that come along with the asset discovery, risk, and vulnerability management. But as a cloud-first security company, we focus on the secure remote access wherever there's an intersection of internet with the factory floor. So let's talk about the Zero Trust Exchange. Why is it relevant in the OT security or the IoT security context? We're not talking just about users connecting to their apps. So this whole concept of brokering two connections together, making sure that there's no network level access is extremely important when it comes to the factory context, right? We do not want to enable full car plants network access. It always has to be least privilege based. This is where the Zero Trust Exchange shines. Think of this like it's proven itself in the IT space for 10 years. It's now ready for OT security. It's now ready for industrial IoT. So how does this work? We are all about reducing the attack surface, right? We want to reduce the attack surface down to nothing. If your firewall is exposed to the internet and it's exposing all your factory locations, that's antagonistic to what you want in terms of security. So that's what Zero Trust brings to play, right? There's no attack surface whatsoever. Even our modes of connectivity, replacing VPNs and firewalls is all about reducing the attack surface. Last but not least is making sure that there's no pass-through connections. So any internet access that happens, any application access that's happening has to be inspected. So keeping in mind these three tenets, you can see how it's really applicable to the factory context, to the industry context that we're talking about here. So let's examine the secure application access or the secure remote access use case here. So how does it work? You have third parties or you have employees who have to connect to your OT systems, and they need privileged access coming into your factory floor. So if you look at the Zero Trust components, we are talking about what we call as a client connector, which runs on the client devices. And in a short period of time, Manish here will demo that. When he's demoing it, keep in mind, he's going to show you the client connector running from his devices from an emulator. So you need the client connector. You also need an ID provider, which is not shown in the diagram here, that allows you to establish the user identity. And then the last component there is the app connector portion of it. All of this is achieved making sure that there's no inbound ports either on the client devices or on the factory side. This is how your ICS or your OT systems remain invisible. That's the important part here. And it's Zero Trust Exchange, where it's brokering this connection. A lot of times we get the question of, hey, if I don't want to connect to the internet or hairpin across to the internet, can I make my Zero Trust Exchange run locally? The answer is yes. You can deploy it as a private service edge and make it happen. You can have a deeper session regarding this. But this is, in effect, at a high level, how this works. And then internally, once the connections come to your app connector, we're advising to use some level of VLAN segmentation or some segmented networks within which you'll have RDP or SSH-based systems to segregate and connect to each of these OT systems here. All of this is cloud delivered, so that's the beauty of it. So there are multiple customer deployments that we can talk about. This is the other use case of internet access. So when your OT systems want to have internet access to securely. So we have enhanced this even further now that an ICS employee can actually just have internet access either through our secure web gateway, and you can actually enhance it with browser isolation, making sure that there's a look but don't download or don't touch policy there. So these are the two main use cases. Now let me get into the most interesting one, which is a variation of the secure remote access. This is what we have been working with one of our partners, Siemens, largely. And they have this industrial edge platform called the Zscaler platform, which is essentially running a Docker container platform on Debian Linux. This is where they require access from their field engineers, remote administrations, business users. They want to get access to applications running on that industrial edge platform. And since these industrial edge platforms are running in different customer environments, it makes it quite challenging to run VPNs and open up firewall ports and such. The solution here was to make one of our zero trust components, the app connector, run in a container form factor. And that's exactly what we're doing here. There are quite a few benefits of doing this. And one of the key things here is only the authorized users even get to see the existence of these systems. So without much talking, let me switch it over to Manish, who's going to do a product demo here regarding this exact secure remote access use case into OT systems, which is widely applicable, not just in the industrial context, but in the industrial IoT gateway context as well. Let me stop share here and have Manish do the demo.
Thanks, Deepak. I'm going to give you a demo of our secure remote access solution. Since we are all working from home lately, I'm going to show you access to my home lab rather than an actual OT environment. And all of this via the Zscaler Zero Trust Exchange. Here you can see my home network. It has a bunch of laptops, mobile devices, and also a bunch of servers running on my Intel NUC. What I'm going to show you now is by introducing a Zscaler app connector, I can now access both the systems as well as applications running on these systems from outside a home network. For this demo, I'll be running the app connector on a Raspberry Pi 4 running Ubuntu. The app connector is deployed as a Docker container. In the OT side, we are seeing Docker as a way to introduce functionality. And so we really see this as a very valuable addition. These Docker containers could be installed on devices, not only on the factory floor, but lately we're having customers who want them deployed on ships on the sea, oil rigs in the ocean, ambulances on the road, or even drones in the sky. All I have done to provision this is install Ubuntu on the Raspberry Pi and have it connect to my Wi-Fi access point. There are other traditional home networking gear like a switch, a router, and obviously my cable modem, but these are very typical networking gear. Without opening any of the ports, I'm now going to securely access any of the systems on my network securely. And these applications could either be Kubernetes dashboard running on my Ubuntu server, or actually access any of the systems here via SSH or RDP. When I install this ZPA app connector on the Raspberry Pi, it opens an outbound TLS connection to the Zscaler Private Access Cloud. All access to the app connector is brokered by the ZPA cloud from authenticated users. Out here, I have my own tenant where I have provisioned the app connector. You can see here there's one instance of app connector, the Pi 1, and it shows that it's connected and it has been upgraded recently. And I've also configured an identity provider to authenticate users in order for them to access any of the applications or systems via that app connector. In my ZPA tenant, I'm using an Okta instance. You can use any of the supported IDPs like Azure AD, ADFS, Ping, and more. I'm now going to switch and show you what an actual end user flow looks like. This is a web page that contains emulated Android tablet from our friend Appetize. When I click on tap to play, it launches a virtual device, which is actually spun up in one of the many data centers that Appetize operates out of. When I launch a device, it spins up from an available data center and renders the output on this HTML5 page canvas. When I click on this button, Open Kubernetes K8s Dashboard, it opens a site which is actually running on one of the servers in my home lab, which is Ubuntu Service House Local. As you can see, you get an HTTP error saying that this site cannot be reached. And that's normal because this emulated session is running outside of my network. Now I'm going to show you how I can enable secure remote access by utilizing another core component of Zscaler Private Access, which is a Zscaler Client Connector. So I'm going to launch an Android app, which is available on the Google Play Store. And I'm going to log in using a user which is provisioned in my Okta tenant with this Zenith at sahu.house. Now, I've done an additional configuration to let my tenant know that any user which has the email suffix of sahu.house will now utilize that Okta tenant to authenticate the end user. So when I actually click on login, it determines that this is a user coming from a domain which is registered with Zscaler and asks me to log in with my Okta tenant after forwarding me to the Okta login page. So I've entered my username, and now I'm going to enter in my password and click verify. So right now, it's just a simple credential, but based on the policies configured in the identity provider, you could have a second factor, multiple factor, you could have a passwordless, a WebAuthn, or any of the factors configured in your identity provider. At this point, the Zscaler Client Connector begins the enrollment process and begins the process of connecting to the ZPA cloud. What it is essentially doing is having certificates deployed to the device and creating that secure outbound TLS channel to the ZPA cloud. When I click on this button, which says open URL ip.zscaler.com, it shows me some information which is very specific to Zscaler. It tells you additionally which particular instance of ZPA Cloud it is accessing. Here you can see it's using Zscaler Beta, and also the location it is coming from, in this case, Washington, D.C. And that is an important feature of Zscaler because Zscaler connects the user to a point of presence which provides the best experience to the end user. In this case, this particular virtual image of Android tablet was actually running from the Washington, D.C. data center. And that's why when the user authenticated and began the process of enrolling with the cloud, it ended up choosing the closest location, which is Washington, D.C. So this is very useful, especially more if users are dispersed around the globe. We have almost 150 data centers, points of presence. So it provides a very optimal experience for end users and provides a fastest path to the location which you're trying to access. At this point, if I were to click on this button again, which is Open K8s Kubernetes dashboard, you can see that this time, instead of returning an error, is actually showing me the Kubernetes dashboard. And this is a server running on the Ubuntu server on my network. And now you can access the site just like you would do if you were running this locally or accessing this locally in your network. ZPA can broker the connection with specific access policies. So you can make the policies as permissive or restrictive as you want it to be. You can specify a policy which says that this user is only allowed this particular app running on this particular server, or you can tell it it can access any of the ports, either TCP or UDP, or you can deny access to SSH or RDP. All of this is configured out here as part of the application segments and the server groups. And in this scenario, I've specified that any user which is authenticated with the Okta identity provider can access any application in this TCP port ranges. You can have all the diagnostics and the live logs. You can either access them here or send it off to your SIM for more fine-grained analysis. So you've seen very quickly that by leveraging an app connector, which is very easily deployed in any kind of form factor, in conjunction with the Zscaler client connector, which the end user is accessing, the Zscaler private access cloud has brokered secure remote access into any of the systems in a network. We feel this is a big game changer for OT network and security, and we look forward for you to utilize this in your own environment. That's it from me. Over to you, Deepak.
Thanks, Manish, for that fantastic demo there. We hope to see more of such demos. But let's continue with some of the use cases here, right? So we talked about how this exact same secure remote access can be used in the context of industrial IoT gateways. We have multiple engagements regarding the same. The use case remains the same. Here, there's a technician, somebody from the factory, somebody that's authorized to look into these IoT gateways. It's about remote access, right? So a lot of times these industrial IoT gateways are deployed on remote locations, like an oil rig or on a ship or somewhere. You can't just fly over somebody to just do diagnostics on. At the same time, you want secure access. You don't want always on VPN kind of connectivity. So all those benefits are exactly available here. And the form factor in which our product is running allows you to do that. It's taking very little CPU, very little network usage, and it works really well over high latency, low bandwidth connections here. And this is one of my other interesting use cases, which is about the secure internet access. So here, we have a different section where we talk about securing point-of-sale systems, securing handhelds. It's very similar. So if you have an IoT gateway that is Linux-based, or it's based on one of the operating systems where you can run the client connector, you can think about the use case here is authenticating the device using some kind of machine authentication, or there could be a user behind it as well, and using that to connect to the applications or to connect to the internet. So we are bringing about consistency, whether it's devices or whether it's users connecting to the internet. You can now have consistent access. Typically what happens, your IoT devices are reaching out to the internet for software updates, or they're reaching out to the internet to update data in a database or from IoT platform. They're not doing the same exact things as a user is doing. So you can get extreme control when you're able to bring in internet access through the Zscaler platform. Let's look at another way of doing this, right? So a lot of times you can't deploy agents on these devices. So we have a new product upcoming called the branch connector. And if you go back to the safe harbor statement, we're talking about futures here. So the branch connector effectively operates as a default gateway. So now it takes over the user, the device identity. It's able to use both the Zscaler internet access or the Zscaler private access to achieve the same functionality as the Zscaler client connector. Not much different here, but it extremely simplifies your deployment model, because you could have literally have hundreds of devices behind the branch connector. As long as that IP segment is protected through the branch connector, all the same policies will apply. Let's talk about next steps, right? So we talked a lot about these use cases. One of the key things you need to understand here is like, how do you know where to start? So the first thing you need to do is you need to get an attack surface analysis, which will cover all your manufacturing locations as well. And don't be afraid, we're not going to go and start discovering these things by sending packets to your systems. We're looking at publicly available information like Shodan, like DNS, like just simply Googling for it, to be honest with you. Right? So this is a very interesting report that you'll get. Based on that, you can start prioritizing which of these locations you need to go and look at first. Then I would suggest doing like a virtual architecture workshop, because a lot of times what happens is your business side is the one that's managing these factories. They need to hear from other customers what they're doing. So doing a virtual architecture workshop helps you figure out whether you can actually go and do like on-floor shop segmentation at all. Like, can you actually do that segmentation piece of it? Do you have enough downtime for it? So it brings out a lot of these details that's required. And you could effectively do protect. I'm not saying all your locations. We understand the OT world is not as simple as the IT side of the house. So at least one of your factories, one of your locations, you should be able to pilot and see how well this protection works. I've had customers who have removed their industrial firewalls because it is actually creating downtime. They're creating downtime to a large extent. So think about it. Plan for this. You need to make partners on your OT side of the house as well. But we feel very confident about making this happen. We are here to answer any questions. If you're able to find the chat window regarding these questions. I know we covered through a lot during today's session. We talked about secure remote access. We talked about secure internet access, secure application access. We talked about OT systems and segmentation. We brought in new concepts about extending zero trust. So we know it's a lot. We are happy to have one-on-one conversations to assist you through this journey of zero trust. With that, we'll leave you with our Zscaler manifesto regarding how we help you manage your risk, reduce it, and help you drive your digital transformation. Thank you.
Thank you.